What's going on, everyone? Welcome back. Patrick here, and moving on with STEM leaf plots, we're now going to do another example. So the number of people inside 20 Starbucks locations at 9 a.m. were sampled in Toronto with the results below over here. So what this means is that in the first location that you looked at, there were 15 people in that Starbucks at 9 a.m. In the next location, there was 20. In the next one, there was 24. Etc., etc. So notice there are 20 observations here for each of the 20 locations that you sampled. And we got to create a STEM leaf plot of this data. Now notice that most of these are double digits. They are two-digit numbers. There's a couple of single digits like the 7, 4, and then the 6, and then the rest are two-digit numbers. Now, when we're making a STEM leaf plot, if you remember, the leaves over here, they're always going to be the single most right digit. It's always going to represent a single digit. It's going to be the one to the most right. And then over here, these stems here are the remaining digits. Now, notice that what's the lowest number here? The lowest number is 4. And then the highest number is 24. So notice that the stems here, the highest number for these stems is going to be 2. Because remember, the stems represent all of the digits other than the rightmost digit. So the rightmost digit of the highest number 24 is this 4 here. So then the other remaining digits in this case is 2, and because this is the highest number in this data set, then we know that the stem is going to be, the highest number is going to be 2. And then we're also going to have 1 here. So for all of these observations starting with a 1, like this 18, this 19, this 15, etc. Question is, how are we going to deal with the 4, the 6, and then the 7? Because notice that the rightmost digit, these are all single digits, so the rightmost digit is the 4, the 6, and then the 7. So notice that there are no other digits remaining, so what is going to be the stem for these single digits here? Well, what we can do is we can add like a 0 in front. Right? So we could represent it as 0, 4, 0, 6, 0, 7 instead of just 4, 6, and 7. And this puts it in the same format as the other double-digit numbers. So that would be 0 here. So if we ended up having like a 0, 9, that would mean that one of the observations in the data would be just a single digit 9. Versus if we had a 9 over here, then one of the other observations would be a 19. Right? So there's kind of like this imaginary 0 here, just so we can make a stem for all the single digit numbers. Just thought I would mention that. So now that we have the format of the stems, we got 3 stems here. Let's fill in the leaves for each of these stems. So 0, these are again the single digit numbers. So we got 4, 6, and 7. So we would put 4, 6, 7. Remember, these always have to be in order. So 4, 6, and 7, those go away. Now, all of the numbers starting with a 1, notice there's going to be a bunch. So what I'm going to do is I'm just going to list them out first. They may not necessarily be in order, and then I'll put them in order after. So starting with this 15, we got a 5, 11, we got the 1. This 18, we got an 8. We got this 1 here. Another 18, 9, 5, 8 again, 10, so that would be 0, 17, and then 15. And I think that is all of them. Yeah. Now moving on to 20, or any of these observations starting with a 2. So notice we got this 20 over here. So 0, 4, 2, we got another 0, we got another 1, and then we got another 1. So notice that both of these stems here, they are not in proper order, so we're going to have to rearrange it. First thing I like to do though before rearranging it is after I make this, I like to count all of the leaves just to make sure that it's the same number of observations. So notice we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Right, so 20 leaves for 20 observations, and hopefully I didn't mess any numbers up in between. I think I'm good though. So now what we got to do is we got to put these in order. So let's start with the 2. So we'll have 0, 0, 1, 1, 2, and 4. So there are 6, and over here I have 6 as well. So I'm going to rewrite this as 0, 0, 1, 1, 2, 4. And now all of these I got to put in order. So we would start with this 0. Let's do it over here actually. So we'll have 0, we'll have 1 and 1. What would be next? Next would be the 5. So we'd have 1, 2, 3. So we would have 3 5s. And then we'll have 7 would be next. And then the 8s, 1, 2, 3. There are 3 8s. And then we have that 9. Notice here we have 2, 4, 6, 8, 10, 11 observations. 2, 4, 6, 8, 10, 11 observations as well. Okay, so erasing all of this, put it in order. We got 0, 1, 1, 5, 5, 5, 7, 8, 8, 8, and 9. Right, and that's basically my process of making a stem leaf plot. Perhaps maybe you have a quicker process, but this is kind of how I go about it. Right, so we have this stem leaf plot for this data right there. Now notice if we take this stem leaf plot and compare it to the one in the previous video, in the previous example, notice that this one has fewer stems. So we got 3 stems here. Versus in the previous one, I think we had 6 stems. And notice that the previous one, it was just more nicely spread out. Versus this one, we have fewer stems. And notice that these leaves here, especially this one, it's really sticking out a lot. And also notice that in this middle row here, most of the leaves, they're kind of clustered in between 5 and 9. And then we have 3 other ones, 0, 1, and 1. So notice that these leaves here, they're kind of closer to this stem. And then these ones are closer to this stem. And so what we can do here is we can actually extract more detail. And the way we would do that is we would create more stems. And the strategy, I mentioned this in the previous video, when you have too few stems, what you can do is something called splitting stems. And here's how this is going to work. What we're going to do is we're going to take this 0 here, this stem of 0, and we're actually going to write it twice. Same thing with the 1, same thing with the 2. Like that. And now what we're going to do is that the leaves that are going to go for this first 0, this first stem here, are going to be all the leaves that are from 0 to 4. Remember that the leaves here, they're always going to be a single digit. So they're always going to fluctuate between 0 and 9. And between 0 and 9, inclusive of 0 and 9, that is 10 digits. So 0 to 4 would be the first 5. And then for this second 0, this second stem, we would have 5 to 9. Same thing here. For this one here, it's going to be all the leaves from 0 to 4. And then for this second one, this fourth stem, in this entire stem leaf plot, this is going to be from 5 to 9. Same thing here. For this first 2, it's going to be from 0 to 4, 5 to 9. Okay, so if we follow this pattern, notice that 0 to 4, notice it's only going to be one of them. So it's just going to be that 4. Because notice that the 6 and the 7 is between 5 to 9. So the 6 and 7 would go here. Let me actually put these a little bit more to the left. So 4, 6, 7. And now for the 1s, between 0 and 4, I already circled them. So it's 0, 1, 1. And then between 5 and 9, it's going to be all of these circled. So it's going to be 5, 5, 5, 7, 8, 8, 8, 9. And then for the 2, between 0 and 4, notice it's actually going to be all of them. Notice that there are no digits here that are between 5 and 9. So we can actually erase this last row. We don't even need it. And we would just rewrite all of these here. 0, 0, 1, 1, 2, 4. And so notice now that this is giving us a lot more detail than this is. Because what this is saying, what this is telling us, is that most of the observations are clustered around here. They're actually clustered between 15 to 24. Versus if we were looking at this, we would think that the observations are more clustered between 10 and 19. But really, if we look at this, most of the observations are clustered between 15 to 24. Right? So we're just getting more into detail. This gives us a lot more detail after we split the stems, took the 0, kind of split it up, took the 1, split it up. That's where that splitting stems terminology comes from. This stem leaf plot, we can extract more information than this one over here, more detailed information. Now, in the previous video, I mentioned how we could take stem leaf plots and we can rotate them by 90 degrees to the left. And what that will give us is the general shape of the histogram, if we were to make a histogram for that same data. So this stem leaf plot, the original one, I shifted it, got that after rotating it. And then this one, I rotated it and got that. And notice how these shapes are kind of different. Now we're actually going to get into more detail in future videos talking about shapes of histograms and stuff like skewness. But notice that, just to give a brief maybe introduction to those videos, notice that this here, it kind of looks a little bit symmetrical, right? Maybe this, there's more observations here than here, but notice that we have this large kind of bar, if you will, for the histogram in the middle. And we got these 2 smaller bars on the side. So this, if you look at it, the shape of it, you may think it's a symmetrical distribution. Versus this one, notice that it's not symmetrical. Because if we draw kind of like a line following this, notice that this peak here, it's more to the right. And then we have a bunch of smaller observations to the left. What this is called here, again, we're going to get into more detail about this in future videos. This data here, it's skewed to the left, or negatively skewed, meaning that this tail here kind of extends out further to the left. Versus notice these tails are kind of like symmetrical. Right? So when you look at the actual data in detail, again, there's more data that's clustered on that right side. And then that's the same thing as more data being clustered here at the bottom of the stem leaf plot. And it actually makes sense if you think about the scenario that you're looking at. You are sampling the number of people inside a Starbucks location at 9 a.m. So 9 a.m. is when most people's workday is starting. And so everyone is going to get their morning coffee, right? So it makes sense that you're going to have more people in those Starbucks locations at 9 a.m. versus less people. Now, at another time of the day, maybe at like 2 p.m., this shape, this kind of pattern may be different. Okay, there may be actually less people at that time. So this can change to being skewed to the right, where all of this would be higher for this less number of people, right? And then like the Starbucks being packed at 2 p.m. Again, it depends on the locations, but you know, if you average it out over all of them, there may be less people here. Anyway, thought I would mention that you can, with the splitting of stems, you can extract more detail and you can kind of see shapes a little bit better, especially if you look at that resulting histogram. But again, we're going to go into more detail about shapes of distributions and skewness, etc., etc. But yeah, just wanted to introduce that strategy of splitting stems. So it's a strategy used if you run into a situation where there's too few stems in your stem leaf plot, too many leaves. You could split the stems up and then you end up getting a nicer stem leaf plot to analyze.